Okay, so we're doing chapter 25, Averages and Statistics, in my new book, Overcoming ACT Math. And if you're interested in getting it, it is available on Amazon. So before I get started, I wanted to remind everybody that look at the description for any updates over time or any extra questions that I decide to add. And then make sure that you do the problems by yourself first for the best results before coming back to this video for explanations. So first we're going to go over some just basic terminology that you need to know in order to successfully do this chapter. So it's going to be that the first thing is that you have to know what mean, median, and mode are. So with mean, I like to think of it as it's the meanest one because people usually know what each of those are. They just mix up which is which. So mean is the meanest one because it requires you to do the most amount of math. So it's the sum of all the items in your list of data divided by the number of items. And then you're going to have your median, which is kind of like the median in a road is how I remember it. This is just your middle number when you line up the numbers from least to greatest. That's important. You have to remember to do that. And then we have mode, which I remember as it's spelled similar to most at the beginning. So it's the most frequently occurring number in the list. So the number that shows up the most amount of times in a list. And then we have range, which is just the highest minus the lowest number in our list. So now what we're going to do is we're going to start with number one and do some practice with these terms. So let's first calculate the mean. So the mean for this would be done by adding all of these numbers. So I would do 4 plus 9 plus -5 plus 0 plus 6 plus -2, and then dividing by how many numbers are in my list. So I have 1, 2, 3, 4, 5, 6 numbers in my list. So I have to add that all up and divide by 6. So when you put that all in your calculator, what you're going to get for your mean is 2. Now for median, so this is mean. For median, we need to put our numbers in order from least to greatest. You could also do greatest to least if you want, but I just tend to always do least to greatest. And what I like to do also is I cross out each number as I put it in my list so I don't accidentally write a number twice. So this is just me putting it in order from least to greatest and crossing out the numbers as I go. So now that I have my numbers in order, median, remember, is the middle. So we have to look for our middle number or numbers in this case. In this case, we have 2 numbers in the middle. Now, sometimes people struggle to figure out what's in the middle. Think of it like this. If this is a line of people, who's going to be in the middle? Like, don't think of them as numbers, really, just kind of like places. So, like, these are the people in the middle of the line because they have 2 people in front and 2 people in back. They're balanced with how many people they have in front and back of the line. So if we have 2 things in the middle, 2 numbers in the middle, what we have to do is take the average of those 2 to figure out what the actual median is. So we're going to do 0 plus 4 divided by 2, and that's going to be 2. So our median is also 2. Now, mode is the number that occurs most frequently in our list, and you'll notice that there's no number that repeats more frequently than any other number, so there is no mode in this case. We don't have a mode. Thanks for the likes and shares, guys. And then we have range. So range is going to be the highest number in our list, 9, minus the lowest number in our list, -5. So our range is going to be 14. So let's go to number 2. It says the average of all of this can be represented by. So average is just another term for mean. So we do the same exact thing as we would do with mean. And what we're going to do is we're going to add all of these up and divide by how many things we're talking about. So we add up all of these terms, and we're talking about 3 items in a list or 3 numbers in a list. So to find the mean, it would be represented by this equation. So let's just simplify it. So P plus 2P is going to be 3P. And then we just copy down everything else, and we can divide each of the top terms by 3 to get P plus R. So it should just be E. Someone said that they're glad to find the live. I'm glad that it's helping you guys out. Please like and share the live. So then let's go to number 3. So it says Ella did very well on her biology exams this semester. She scored a 90, 88, 92, and 94 on her 4 exams. Ella has one more biology exam coming up. What score must Ella receive on this final biology exam so that the average of all her exams for the semester is 4 points higher than her current exam average? Okay, so let's talk about her current exam average. So her current exam average, remember that's the same thing as mean, we can figure out by adding up the scores that she got on all of these exams, these biology exams, which they've given us, and then divide it by 4 to figure out what our mean is. So when you put that all in your calculator, what you're going to get is 91 for the current, her current average, her current mean. So now we want to know not just her current mean, that's not what they asked. They asked what score must Ella receive on the final exam so that the average of all her exams is going to be 4 points higher than her current average. So her current average is 91. We want 4 points higher than that. So we want 95 to be her new average. So 95 is going to be the new mean or average. And we already know from adding up all these numbers before that this is going to be 364 plus whatever this mystery grade that she gets on the exam is that we're solving for, divided by, there's now 5 exams that we're talking about. And then all we have to do is multiply each side by 5 and solve for x after that. So we multiply each side by 5, and we're going to get 475 is equal to 364 plus x, and subtract 364 from each side. And when we do that, we're going to get that x is equal to 111. So, okay. Someone asked in the comments, do you help with math, with college math courses too? Yes, I do. Up to a certain level, just like calculus and stuff, but nothing like crazy, not crazy, like super high level math. And then let's see, yes, you do divide by 4 initially. So then let's go to the next one. So it says, use the box plot below to answer questions 4 through 10. The box plot shows the number of siblings each student has in Miss Garcia's class. So what is the median here? So when you're looking at the box plot, the median is the little line in the middle of the box. I mean, not necessarily in the middle, but you know what I mean. Like, it's the line inside the box. That represents your median, so the median is going to be 6 here. What is the minimum value? So the minimum value is going to be the part right over here. It's the lowest value, like the minimum. So it's going to be 2. And then what's the maximum value? That's the opposite. It's going to be the highest value over here, which is going to be 8. And then what is the range? So the range is going to be the high minus the low. So 8 minus 2. And that's going to be 6. And then we want to know what's the interquartile range. So interquartile range is going to be basically this portion right here. So it's the high of the box portion and the minus the low of the box portion. So this would be 7 minus 4. So 7 minus 4 is equal to 3. So that's our interquartile range. So then let's go to number 9. It says, which of the following is true about the box plot shown above? So let's see. This is ACT math. And then it says the median is greater than the mean. So let's see. The median, meaning like this little line, is greater than the mean. So if we look at the box, there's a larger portion of the box to the left, which is representing the mean. So this is the median. This would be like the mean is over here. So the median is greater than the mean. Yes, that tracks. So then number 2 says the upper quartile is smaller than the lower quartile. So the upper quartile is going to be this portion right here. And the lower quartile is this portion over here. This is, in fact, smaller or shorter, so that tracks as well. And number 3 says the box plot has a positive skew. So when I'm thinking about skew, what I like to think about is where the bigger part of the box is. So if the bigger part of the box is towards like the negatives, on a number line, I think about it as it's negatively skewed, and then the opposite for positively skewed. Like if the bigger part of the box is to the right, I think positive skew. So it says the box plot has a positive skew. That means that the bigger part of the box would have to be on the right, which it's not. So that does not track. That's not correct. So it would just have to be 1 and 2 only, G. And let's go to number 10. Which of the following is true about the box plot? Please teach trigonometry. I will. There are 2 chapters in this book on trigonometry, so we'll get to that. Which of the following is true about the box plot shown above? Most of the siblings have more than 5 siblings. So let's see. Most of the siblings have more than 5 siblings. So that would be yes, because the median is at 6. And the median is like the 50% of more would mean that 50% or more of them would have 6 or more students, or siblings, I mean. So that tracks. And then let's go to number 2. Half of these siblings, or half of the students have more than approximately 6 siblings. So half of the students have more. It's hard to say that. Have more than approximately 6 siblings. Yes. So again, the median is at 6, so that tracks. And then we have half of these students have approximately 4 to 7 siblings. So 4 to 7, that would be like here to here. So the box, the interquartile range is 4 to 7. So that tracks as well, because the interquartile range would tell us the middle 50% of people. So that would track as well. So it would be E1, 2, and 3. Can you teach calculus 1? So I'm trying to stick to just ACT and SAT math for now, but as my channel grows, I will add in calculus as well. But I'm trying to promote like the books that I've written. I haven't written a calculus book. So let's go to number 11. Let me just get this out of the way. Okay, so number 11 says, student A has taken 30 quizzes a semester. His highest quiz score is a 90. Student B has gotten the same exact quiz scores for all 30 quizzes, but gets the opportunity to take an extra quiz and scores an 100 on this quiz. Which of the following must now be 10 greater for student B than for student A? So initially they had all the same quiz scores, right? And initially both of their high quiz scores would be a 90 if they had all the same quiz scores. But then student B gets a new high score, a new highest quiz score of an 100. So now the maximum has changed, but the minimum has not, because they still have all the quizzes before, so they still have the same minimum. But student B now has a new maximum value of 100. So if you think about range is just the high minus the low. So if the highest value has changed and gone up by 10, and the lowest value remains the same, then the range will also go up by 10. So it would be J. This is a great channel. Do you have a YouTube? Yes, I do. It's the same name as this. And I'm glad that you're enjoying. So then let's go to number 12 through 13, which are both going to be a part referring to this graph right here. The bar graph below displays the annual household salary in thousands of dollars versus the number of households in a particular neighborhood, i.e. 22 households make more than $75,000 a year. Okay, so then let's see. Number 12, it says, if a household in this neighborhood is randomly selected, then what is the probability that the household's annual salary is $55,000 or more? So the probability that it's $55,000 or more. So let's look over here. So that would be, there's 10 that are in the 55 to 64,000 range. And then there's going to be, for the 65 to 74,000 range, there's going to be 25 households. For the more than $75,000 range, that's going up to, well, they said exactly 22 households. So this is what's representing $55,000 or more. It's this 10 plus 25 plus 22 households. So it would be 10 plus 25 plus 22 over the total number of households that we're talking about here. So the total number of households, we would just do the same thing counting for the lower ones. So it would be for less than 15,000 is 10 households, for 15 to 24,000 is 20 households, for 25,000 to 34,000, that's going to be 12, and then for 35,000 to 44,000, that's going to be 5, and then for 45,000 to 54,000, that's going to be 7, and then we're just going to add all that up on the bottom to get our bottom number. So the bottom number is going to be 10 plus 20 plus 12 plus 5 plus 7 plus 10 plus 25 plus 22. So then what we're going to do now is we're going to basically just put that in our calculator to find the probability. So when we put that into our calculator, what we're going to get is 0.5135 yada yada yada. And let's see which one's closest to that. So that's just going to be E. So let's see for number 13, what is a possible median annual household salary for this particular neighborhood? So we're looking for median. So remember, median means middle. So when we added all this up on the bottom, that was 111 households, like total households that they're talking about. So if we think about 111 people in a line, who's going to be in the middle is basically what we're thinking about. So if we're thinking about 111 people or households in a line, the middle value is going to be number 56, like household number 56, because then there's going to be 55 to the left, 55 to the right. Household number 56 is going to be in the middle. So we have to look for household number 56. So 10 plus 20, that's going to be 30. 30 plus 12 is going to be 42. 42 plus 5 is going to be 47. 47 plus 7 is going to be 54. So that means that it's definitely going to be in this part right here because we get to 56 in this portion of the graph, the 55,000 to 64,000. So any number between 55,000 and 64,000 would do as the median. So that would be H. Thank you guys for liking and sharing the live. Let's now go to the next one over here. So we have this little table right here. Concert ticket sales for a popular alternative rock band are shown below. What was the average increase in annual ticket sales for the band from 2019 through 2022? Okay, so the average increase from 2019 to 2022, what we're going to do is we're going to subtract these two values and these two values. So on top, we're going to have the 5,570 tickets sold in 2020 minus the 1,567 tickets sold in 2019. And then we're going to subtract the years right here. So when we do that and we plug that into our calculator, what we're going to get is B. And now we have number 15. What is the average number of tickets sold per year between 2020 and 2022? So 2020 and 2022 would be, we're just going to, or 2020 to 2022, we have to basically like ignore the first one up here. And we're finding the average, so we're just going to add these all up right over here. So we're going to do like 2,245 plus 3,489 plus 5,570 over, and then it's going to be 2022 to 2020 that we're talking about. So we're going to plug that into our calculator, and when we do, we are going to get that it is J. So now let's go to, oh, I skipped one. Let's go to number 16, and oopsies, hold on. There we go. Oh, and I have to check something really quick. Hold on. I'm supposed to be editing this as I do that, so let me make sure that those were good on the answer key. Yes, okay. So let's go to number 16. How much did ticket sales increase from 2020 to 2021? So 2020 to 2021 would be here to here. So we're going to say, okay, the change over the original amount times 100. Sorry, it's 2020 to 2021, yeah. So the change is from 2,245 to 3,489. That's the change, like we're going from one to the other. And then so to find that change, we have to subtract those values. So it would be 3,489 minus 2,245 over the original value, which would be the 2020 value. So that would be 2,245, and then we multiply that by 100. Or you could do this in your calculator and just know you have to move the decimal 2 spaces to make it a percent. Either way works. So when you do that, what you're going to get is A, 55.4%. So now let's go to number 17. Assume the sum of 207 consecutive integers is 0. What must be their median? So we're going to add 207 consecutive integers. What must be their median? So that means, let me think about that for a second. So that means that if there's 207, that means that 103 negative numbers have to cancel out with 103 positive numbers, and then 0 would be the middle number. So then that would be, the median is 0, so it would be E. Okay, so then let's go to number 18. So it says, which of the following graphs best represents a strong positive association? So strong positive association is just like, it kind of looks like a line, but with dots going from left to right up like this. That would be the positive one. And like negative would be the line that's going, not a line, but like dots that look like they're making a line like this, sort of. So a strong positive association is like this. That's what we're looking for. So if we look at all of these options, the one that looks like that would be F. Okay, so now let's go to, let me get this out of the way actually, and let's go to number 19. Thanks for liking and sharing the live, guys. So number 19 says, the table below shows the number of books read by 80 students during the summer. So what is the average number of books read per student? Okay, so average number of books read per student. What we would do is we're going to, we could technically, if you wanted to, write out a whole list of like, I'm going to write the ones 15 different times and then the twos 13 different times. Or you could just do the faster way, which is multiplying, to figure out, because if you have 1 and 15 times in the list, that's the same as 1 times 15. So you could just multiply each of the values together, add them up, and divide by how many values there are, which would just be how many students you're talking about, which is 80. So that's what we're going to do. We're going to do 0 times 25 plus 1 times 15 plus 2 times 13. And then, oops, it's supposed to be a 2. 2 times 13 plus 3 times 7. Plus, and I'm running out of room, but this is all just we're imagining in one line. So then that's going to be 4 times 11 plus 5 times 9. And then we're going to divide that all up by the 80 students. So let's see, when we plug that into our calculator, what we are going to get is going to be, let's see, that would be B, 1.9. What is the mode in this list? So remember, mode is the number that occurs the most frequently in our list. So if we look at this list, the number that's popping up the most amount of times is going to be 90. So it would be J, 90. And number 21 says, after taking 5 physics tests, Eileen's average score was 85 points. How many points will Eileen need to score on the 6th test to get an average score of 88 points for these 6 tests? So let's first talk about her 5 physics tests. So her average or her mean score was 85. The way we find mean is we take the sum of our data points, which would be the test scores. So let's say this is the sum of 5 test scores, because we don't know what the scores are, divided by how many test scores we are talking about, which would be, let's see, this would be 5. There's 5. So then now what we're going to do is we can say, okay, for the second scenario, when we're talking about 6 tests, they want the average score to be 88. So the average or the mean is going to be 88. And again, we set up our mean formula, but with a different scenario this time. So now there's going to be 6 tests, and the sum of 6 would be equal to the sum of the first 5 plus that 6th test, which we'll call x. Now, you'll notice in the first equation, we could just multiply each side by 5 to find sum of 5, and then plug that in here, and then we can just solve for x. So that's what we're going to do. So when we multiply each side by 5, we're going to get that the sum of 5 is equal to, that would be 425. I'm glad that you guys are enjoying this live. And then what we're going to do now is, and you can follow me as well so that you see my lives more frequently. So then let's go to this one right here, and we're going to plug in sum of 5 now. So now instead of saying sum of 5, we're going to plug in 425. So we're going to say 88 is equal to 425 plus x over 6. So I'm going to multiply each side by 6 now. And then when I do that, I'm going to get 528 is equal to 425 plus x. And then I'm going to just subtract 425 from each side, and that's going to give me that x is equal to 103. So it would be E. Let's go to number 22. At the end of the semester, a professor receives satisfaction ratings between 0 and 100 inclusive from his students. For the first 8 ratings the professor received, the average of the ratings was 85. What is the minimum value that the professor can receive for the 9th rating and still be able to have an average of at least 90 for the first 18 ratings? Okay, so the first scenario that they describe is an average or a mean of 85. And then that would be just for the first 8 ratings. So there's 8 data points that we're talking about. And then this would just be the sum of 8. That's how you would set up the formula for the mean with the numbers that they've given us. Now, for the second situation, they want the professor to get at least a 90 as the average or the mean. And it's going to have all 18 ratings. So the bottom number is going to be 18. So then this top is going to be the sum of 18. Another way to say the sum of 18 would be the sum of 8 plus the sum of the 9th through 18 scores, or ratings, I mean. So now what we're going to do is, if we could figure out the sum of 8, we can plug that in over here. And then we could solve for the sum of 9 through 18, which will help us figure out what the minimum value he can get for for the 9th rating is. So if we multiply each side over here by 8, what we're going to get is that the sum of 8 is equal to 680. So I'm going to plug that in for sum of 8. So then I'm going to have 90 is equal to 680 plus the sum of 9 through 18 over 18. So then I'm going to multiply each side by 18. And now when I multiply each side by 18, that's going to give me, I'm running out of space a little bit, but it's going to give me 1,620 is equal to 680 plus the sum of 9 to 18. So now I just have to subtract 680 from each side to get the sum of numbers 9 through 18, or ratings 9 through 18. So then when I do that, I get 940 has to equal the sum of the 9th through the 18th ratings. Now remember, we're looking for what the minimum value he can get for the 9th rating is. So to find the minimum value, we would have to think, okay, what's the highest value he can get for the other ratings? Well, it said he was scored from 0 to 100. So if he gets on the other ratings, if he gets on the other ratings past the 9th ratings, like ratings 10 through 18, if he gets an 100 on all of those, then he can get, that would be 900, so then he could get a 40 on as the least value. Like that's just like the best scenario where he gets 100 on everything else, then he could get a 90 on that, and that would still all add, or a 40 on all that, I mean, and that would still all add up to 940. So the answer would be H. So then let's go to number 23. What is the sum 9 to 18 in the third row? It's 940 right here. So all I did was I subtracted 680 from each side. And then I got that the sum of 9 through 18, like the sum of the 9th rating through the 18th rating is going to be 940, like when you add all those together. So let's go to number 23. Given that the average of P and Q is 10, so average, remember, is mean, so P plus Q divided by 2 is going to equal 10. And the average of P, Q, and R is 6, which of the following could be R? So then let's do average of P plus Q plus R divided by, now there's 3 terms in our list, is equal to 6. We want to find out what R could be. So we have to find out what P plus Q can be. Well, we can find out what P plus Q can be by multiplying each side over here by 2. So we would get P plus Q is equal to 20. So then this would be 20 plus R is equal, or over 3 is equal to 6. And then we just have to multiply each side by 3. So then that's going to be 18. And then we need to subtract by 20 on each side, and we get that R is equal to -2. So it would just be A right there. Okay, so let me go to the next page. So it says Emma is trying to gather data on public sentiment towards a new swimming pool in her county. Emma decides to ask her classmates about their thoughts on the idea during school. Which of the following could improve Emma's approach? Number one, Emma could ask her dad to ask his colleagues at work about their opinion. So this is where paying attention to the wording really matters. So it's in her county. What she wants to know how people feel about the swimming pool in her county. Now, people don't necessarily always work in their same county. So you can't just assume that the dad works in the same county. So that might not be the best idea. So it's not going to be that one because then it's not representative of who she's trying to figure out likes the pool or not, or likes the idea of the pool or not. So number two, it says Emma could enlist some of her friends to help her collect data at school. So again, we're talking about in her county. She's interested in the people in her county. You go to school in your county, like the same county. So then that's okay. And then Emma could do the same thing at the local park. Again, like local park would be part of the same county. So it would be 2 and 3. So let's go to number 25. So for number 25, it says a box contains 30 black, 40 green, and 50 yellow marbles. Suppose you win $2, $3, and $4 for drawing a black, green, or yellow marble, respectively. If you were to try to determine how much money you could win on average, then approximately how much would you expect to win? So let's talk about the probability that you pick a black marble. So the total amount of marbles right here is going to be 30 plus 40 plus 70. So there's 120 total marbles. The probability that you pick a black marble is going to be 30 out of 120. So if you multiply that probability by the amount you could possibly win, and then you do that for each of the types of marbles, like the green, the yellow, then you're going to find out how much you're expected to win. So you have to do the probability times how much you would make for each of these scenarios. So we would do 40 for the green over the total 120 marbles times $3 for the green plus, and then it's going to be yellow is 50 over the total 120 marbles, and that's going to be times 4. So we're just going to multiply and add those all together. And when we do that, what we should get is 3.16 repeating over and over again. So then it's going to be that's closest to C. Let's go to number 26. It says, given that the average of P, Q, and R is 20, what is the sum of P, Q, and R? So average is mean, so P plus Q plus R, because for mean we just add it all up and divide by how many, which is 3. There's 3 in a list. Has to equal 20. And we want to know the sum of P, Q, and R. So we want to know what is P plus Q plus R. That's what we're trying to find. Well, if we just multiply each side by 3, we would get what P plus Q plus R is. It's equal to 60. So it would just be H. Okay, so let's now go to, let me move that out of the way. And let's now go to, hold on, let me move that. Okay. So then let's go to numbers, hold on. Use the scatter plot below to answer questions 27. The scatter plot shows how far John could throw a ball measured in feet at different ages. So we're referring to this one for the next question. So it says, what was John's average change per year in throwing distance from 13 to 18? So at 13, his throwing distance is going to be 30, because that lines up with 13 there, and it lines up with 30 there. At 18, he's going to have, that's going to be 48 right there. Hold on. That's supposed to be a 48. 48 right there for his throwing distance. So to find the average change per year from 13 to 18, we would just subtract those to find the change divided by the difference in the years. So it would just be 48 minus 30 over the change in the years would be from his 18th birthday to when he's 13. So then we're just going to subtract it on top and bottom and divide, and then that's going to give us 3.6b. Given that the average of 2p squared and 2p is 6, which of the following could be p? So remember, average is mean, so this is saying 2p squared plus 2p, because mean is just you add it up and divide by how many terms there are, which are 2, has to equal 6. So if we just divide this, you can also multiply each side and then divide if you want to, but I'm just going to divide right here because I see like there's 2, 2, and 2. So I could divide by 2 on top and bottom to get, that there's p squared plus p, because the greatest common factor is 2. So that's why I'm dividing by 2, because I can just cancel all these 2's out. So then I get that that's equal to 6. So now I can just say, oh, I have a quadratic. I'm going to set it equal to 0 to solve for what p is. So I'm going to say p squared plus p. I'm going to subtract 6 from each side. When I do that, this cancels out to 0. And then I just get minus 6 here. Now I have a quadratic set equal to 0, so I can just nicely factor this. And when I factor, it would be p plus 3. P plus 3, p minus 2 is equal to 0, because that multiplies to negative 6 and it adds to 1 in the middle, because this is just 1p. We just don't write the 1 in front in math. So this means that p would have to be either negative 3 or positive 2 in order for this to equal 0. So we're looking for negative 3 or positive 2, so it would be just G right there. So then now let's go to number 29. It says the weather forecast predicts a 0.2 chance of 1 inch, a 0.4 chance of 2 inches, a 0.1 chance of 3 inches, and a 0.3 chance of 4 inches of snowfall tomorrow. What is the expected snowfall? So what you would do is you would do the prediction or the probability, like it's talking about the chances, the probability that something's happened, times each of the values, and add them all up. So there's a 0.2 chance that you're going to have 1 inch, so you multiply those. Then there's going to be a 0.4 chance that you have 2 inches, so you multiply those. A 0.1 chance that you're going to have 3 inches, and then a 0.3 chance that you're going to have 4 inches. So these are all being added together, and multiplied and then added together. So when you multiply each of those and then add it all up, you are going to get that would be 2.5. So that's going to be C. And now we're on number 30. It says the mean age of 10 employees in a department is 35 years. If the manager, who is the oldest, retires, the mean age of the remaining nine employees becomes 32 years. How old is the manager? Okay, so let's talk about the first scenario. So the mean is going to be 35. And mean is just the sum of the data points. So the sum of the 10 employees' ages. Those are the data points we're talking about, divided by there's 10 employees. So there's 10 ages in our list that we're talking about. And then the second scenario says that the oldest is going to retire, and then they're going to have the mean of the remaining 9 employees is going to be 32. So for this equation, it would be the mean is 32, and then we're talking about the sum of 9, only 9 employees. So another way to say the sum of 9 would be the sum of 10 minus that mystery employee's age that retired, divided by, we're talking about 9 employees now. So if we can figure out what the sum of 10 is, we can plug it in here and solve for what X is, that oldest employee's age that just retired. So we just multiply each side by 10, and we're going to get that the sum of 10, thanks for the lights guys, is 350. So I'm going to plug in 350 there, so I'm going to get 32 is equal to 350 minus X over 9. So then we're going to multiply each side by 9. So when we do that, we're going to get that it's 288 is equal to, that's going to be 350 minus X. And then we're going to subtract 350 from each side. It's going to cancel out right here, and then on the left-hand side, we're left with negative 62, and on the right, it's negative X. Just divide by that negative 1, and then you get 62 is equal to X. So that employee must be 62 years old. H. Okay, so let me just go and get this out of the way. Okay, so for this one, it says, for her college thesis, Olga created the scatter plot above to summarize the grade levels of different students and the number of hours they need to study each afternoon. Which of the following could be concluded from the scatter plot? Number 1 says there is no relationship between a student's grade level and the amount of time they spend studying. So let's see. If we look over here, there does seem to be, hold on, let's see. So there is... Wait, there's no relationship between a student's grade level. Sorry, the wording's tripping me up. Which of the following can be concluded from the scatter plot? There is no relationship between a student's grade level and the amount of time spent studying. So no relationship. means that they're saying there's no relationship here. There does seem to be some sort of relationship, like it does seem to like tend to increase over here. So I wouldn't necessarily say that. So that would be off of our list. And then number 2 says, if a student enters a higher grade level, then they will start to spend more time studying. So they enter a higher grade level, they would start to spend more time studying. This is the causation versus correlation thing. So they're saying that that causes them to study more. That doesn't necessarily cause them, it just correlates with that behavior. So just because they enter a high grade level doesn't mean that it's going to cause the student to study more. It just happens to tend to be that way. So we can't assume causation from correlation. So that would be out of the picture. So then number 3 says students in higher levels tend to spend more time studying. That's correct. That's just correlation. That's not causation. So it would be just number 3. So then that would be C. Okay. So hold on one second. Let's put this there. Okay. So we're going to go to number 32. It says in a specific physics class, there are 29 students who took a test. The median test score was 85 points. If no students receive the same test score and partial points are not possible, then how many students earned a test score that was more than 85 points? Okay, so let's think about how we would think about that. Okay, so there's 85 points is the median. There's 29 students who took a test. So if I think about 29 students in the line, because median is the middle number. So if I think about 29 students in a line, that means that the person that scored 85 is in the middle of the line, if that's the median. So this is the middle, and then there's going to be 14 students over here, 14 students over here in the line. And then it's asking how many students earned a test score that was more than 85 points. So this is the middle. If we line it up from least to greatest, so that means that there has to be, if there's 14 people in the back of the line, like where it's getting greater test scores, then that means that 14 people got a score greater than 85. So it's going to be G. So then now we're going to go to number 33. It says Emily's semester grade in, oh my gosh. Oh my god, oh my god, oh my god. Hold on. Fuck. Hold on, there's a lizard. No. Oh my god. Oh, fuck. Oh, I can't curse on this. Oh my god, I don't like that thing. Okay. Sorry, I'm back. Okay, so let's go to number 33. So it says Emily's semester grade in her biology class is calculated from her scores on 4 quizzes and 1 final exam. Each of the 4 quiz scores is worth 15% of the semester grade. The final exam score is worth 40% of the semester grade. Emily's 4 quiz scores are 70, 80, 85, and 85. If Emily wants to receive at least an 82 for her semester grade, then what is the minimum score that she will have to earn on her final exam? Okay, so if we're talking about weighted grades, so like each of the quiz scores is going to be 15% of her semester grade, so we would have to do 0.15, because that's 15% as a decimal, times each of the quiz scores. So it would have to be 0.15, because it's worth 15%, the 70 grade. So like if you're talking about all the parts that of her grade that we're talking about, it would be 15% is for the 70 that she got, 15% would be for the 80 that she got, 15% would be, the 85 that she got would be worth 15% of her grade, and same thing for the other 85. That would be worth 15% of her grade as well. So then it says that her final exam score was going to be worth 40% of her grade, but we don't know what that is. But we would still keep up the same pattern, and we would say that it's worth 40%. So 40% of her overall grade is going to be based off of this X test score that she gets on her final exam. And she wants to get at least an 82 for her semester grade. So when we add all these up, we should get 82. So we are just going to multiply all these and combine our like terms. So you just multiply this, this, and this, and add them up. And when you do that, you're going to get 48 plus, and then this would just be 0.4. 0, x is equal to 82. So then you're just going to subtract 48 from each side. And then it's going to be 0.40x is equal to, and then that's going to be equal to 34. And then we're going to get that if we divide each side by 0.40, we get that x is equal to 85. So it would be D. So now let's go to number 34. It says list C and list D each contain 6 numbers. The numbers in list C and list D are all the same except for the number that is least in each list. The number that is least in list D is greater than the number that is least in list C. Which of the following must be greater for list D than list C? So list D, the number that is least in list D is going to be greater than the number that is least in list C. So all the other numbers are the same, except for that one number. So that means if you have all the same numbers, but there's one number that's greater in list D, when you add those all up, you're going to have a greater sum for that the numbers in that list. And then if we think about the equation for mean, and mean is equal to the sum divided by the number of items in our list or data points. We have the same number of data points, but we're increasing the sum, so that means that the mean will increase. So it definitely has to be something with mean in it, so we can cross out G and H. So the mean is definitely going to increase. Now we would have to see, okay, I would see what's in common with each of these. So I'm going to try to see like range. If I can figure out range, if range is not it, then I can automatically pick F if nothing's happening with range to make it greater. So let's focus on the range. So if the range is going to be the high minus the low. So for list D, we have the high number would be the same because it's all those numbers are the same. It's the lowest number in the list that's going to be getting greater. So we have that the high is the same, but this number is getting greater. So we're subtracting more, which means that we would have a lower range actually. So it would be not greater. So then I can cross out J and K, and it's only going to be F. Only the mean gets greater. So let's go to number 35. By how much would the sum of 5 numbers need to increase in order to increase the mean of those 5 numbers by 2? Okay, so how much does the sum of 5 numbers need to increase? Okay, so let's do the sum of 5 plus however much it has to increase, x, is going to be over 5, and that's going to be equal to mean of 5 plus 2, because we're saying that it has to increase by some amount, like the mean has to increase by some amount in order to increase by 2. This is that as an equation. So then if we divide each of these by 5, we could say sum of 5 over 5 plus x over 5 is equal to the mean of 5 plus 2. Oh my god, the lizard's back. Okay, hold on 1 second. Oh my god, I hate this thing. Go away. Go. Get. Stop it. Okay, so then let's go to this one. So sum of 5 over 5, that's the equation for mean. So we're going to get rid of that because it's the same thing. Like mean of 5 would be equal to the sum of 5 over 5. So these are equal to the same thing. So there, I can just cross those out. They cancel out. So then we're going to have x over 5 is equal to 2. So then we're going to have x is equal to 10. So it's going to be E. Okay, so now let's go to number 36. Okay, the city council surveyed 800 residents about building a new park. 480 residents supported building a new park. If the survey reflects the opinion of 28,000 residents, which of the following is closest to how many are expected to support the new park? Okay, so in this survey that they did, 480 people are in support of it out of the 800. So that's the fraction of people that we can expect to be in support of this. So if we multiply that by the 28,000 residents that they want us to guess about, then we would figure out how many are expected to support this new park. So then that's going to be equal to, if we divide this and then multiply by that, that's going to be 16,800. So that would be F right there. Okay, so then this is going to be the last problem. So we have for number 37, 15, 20, and 38 are 3 out of 6 integers. The mean of these 6 integers is 36 and the median is 38. Which of the following could be one of the other 3 integers? Okay, so let's write this in a list. So there's 6 integers, like there's 6 numbers in a list. And then it says that 38 is the median. So, and there's 15, 20, and 38. So 15, 20, 38 is already there. The median, if there's 6 values, the middle numbers would be here. So that means that these 2 numbers divided by 2 have to equal 38. So that would just have to be 38 twice, because 38 plus 38 divided by 2 would give us 38 as the median that we want. So which of the following could be one of the other 3 integers? Okay, so we're looking for what could be in one of these spaces basically. So let's call this x and let's call this y. Okay, so and they told us the mean of these is 36. So let's write an equation for mean. So mean would just mean that I'm adding all of these values up. So I would do 15 plus 20 plus 38 plus 38 plus x plus y, dividing by how many numbers I have in my list, which would be 6. And then it told me that I was going to get a mean of 36. So this was going to equal 36. Okay, so when I add all these up on top, I'm going to get that that's 111 plus x plus y over 6 is equal to 36. Then I'm going to multiply each side by 6. That's going to give me 111 plus x plus y is equal to, so that's going to be 105. So then let's see, all of this has to add up to, hold on, did I do that right? Oh, sorry, I forgot to get rid of, sorry, I multiplied each of the sides and then I subtracted in my calculator. Hold on, 1 second. So it's actually going to be, because I did both of them at the same time. So let me do it one step at a time. Hold on. So it's going to be 6 times 36 is going to be 216. So this is going to be 111 plus x plus y is equal to 216. Then you have to subtract 111 from each side. And that's when you get the 105. So this is 105 is equal to x plus y. Okay, so now what we're going to do is we're going to say, okay, when we add up these 2 numbers, we should get 105, like these 2 numbers right here. And we know that it has to be a number greater than 38 because if these are the medians, right, these are the middle numbers, then these have to be like numbers higher than that. Like it can't be lower than 38 basically. So it can't be 32 or 36. And then, so our options now are going to be C, D, and E. And we have to make sure that when we plug in these options that we would have a plausible answer for what the other integer is. So like, let's say that the integer is 60. Let's say one of these is 60. So 60 plus y equals 105. Well, what would we get for y? So then for y, if we subtract 60 from each side, we would get that y is equal to 45. That's a number that's greater than 38. So is 60. So that's plausible. That would work. Now, if we plug in 67 instead, and we say 67 plus y has to equal 105, we would subtract 67 from each side. So 105 minus 67 is going to be 38. So then we get y is equal to 38, and that can't happen. So it's not going to be that one. And then we're going to have 69 plus y is equal to 105. So then we subtract 69 from each side. So if we subtract 69 from each side, we're going to get 36. That can't happen because we need values that are greater. So it's not going to be that one, and it's just going to be C is the only one that works. Okay, well that is it for today's live. I will see you guys again at 2 p.m. tomorrow. Bye guys.